Hello everyone. Today we're going to go over how to graph compound inequalities. So what is a compound inequality first of all? So we know what a simple inequality is. A simple inequality is just something like x less than 7. So where we have a simple condition taking place. Now what is a compound inequality? A compound inequality occurs when you have two inequalities instead of one, and they are connected by the words and, or the word or. So here we go. We have two inequalities connected by the words and or the word or. So for example, we can have the following: x less than 3 or x greater than or equal to 5. So this is a compound inequality because we have two inequalities and they are connected by the word or in between. Here's an example of another compound inequality: x greater than 7 and x less than 15. So here are two examples of compound inequalities, and they are connected by the words and or the word or, and we have two inequalities taking place. All right, so what is the difference between these two types of inequalities? Because we are going to be learning how to graph them. So what is the difference? So let's take a look at the first one, which is the ones with the word or. So the graph of a compound inequality with an or represents a combination. So it's pretty much a union of the graph. So we're putting the two graphs together and making one graph from both of them. So a number is a solution, so something satisfies the inequality or is a solution to it if at least one of the inequalities is true. So let's write that in. So as long as it's true for one of the two inequalities, then it's a solution to the compound inequality. So again, the word or says the first one is true or the second one is true. As long as one is true or both, then it's a solution. Now the and inequalities represents a combination. That was a mistake. It's an intersection. Sorry about that. An intersection of the graphs. So solution is true for the compound inequality if it is true for both. So again, here it has to be true for the first one, it has to be true for one of them in order to be a solution, where the bottom one and has to be true for both because it's a combination of the answers. So let's go ahead, and today's focus will be just strictly on the or ones. So let's go ahead and do that and see how do we graph inequalities that are compound but that specifically have the word or. So we're going to look at our two numbers that are our two, kind of like our borders that are going to split up our number line. And we're going to start by looking at where that goes. So I'm going to go ahead and put the first one. I'm going to look at this one right here. We have x less than or equal to -2. So at -2, I'm going to put my closed circle because that's less than or equal to. Now for the second one, we have x greater than 1. So I'm going to go ahead and put an open circle at this point. Now my number line has been split into 3 sections. I'm just going to call them A, B, and C just for reference. So my solutions can exist in section A, B, and or C. So it can be all 3, one of them, 2 of them. And I have to figure out where am I going to shade, because we want an or. It's a combination of all the answers. So we're going to be using test points to decide where am I going to shade in. So for the first one, I'm going to pick a point in this first region here. I'm only highlighting it for effect. Do not highlight it on your paper. So we have the numbers -5, -4, and -3 there. Now I have to ask myself, will these be solutions to one of the inequalities? Remember, it has to be true for only one. At least one. So I'm going to go ahead and plug it in. So I'm going to go ahead and plug in this number in. In this case, I am going to choose the number -4. -4 is in region A. I'm going to plug it into the first one and the second one. If it's true for one of them, I'm going to highlight it. So let's go ahead and check that out. So I'm going to check the first one. I'm going to write 4 is less than or equal to -2. So again, I'm checking the first inequality. The question is this true? Is 4 less than, or I'm sorry, -4, because it's in this region here. Is -4 less than -2? And the answer is true, which means I can go ahead and highlight this area. So region A is a solution. I don't have to check the second one because it has to be true for 1. Let's go ahead and do the middle section. I see a -1 and a 0. I'm going to use a 0. So 0 less than or equal to -2. And is 0 smaller than -2? Yes or no? 0 is not smaller, so now I'm going to check the second one to see if it's true for the second one. 0 is greater than 1. And is 0 greater than 1? It's also false. So that means this middle section does not get shaded. Now I'm going to check the third area, which is C. I'm going to use the number 2. So it's 2 less than -2. Is that true? That's false. And I'm going to check it on the second one. Is 2 greater than 1? That's going to be true. So that means this section gets shaded. So that means both of these sections right here get shaded. And this is my final answer. So numbers on the left of -2 and on the right of +1 will be solutions for the compound inequality. Let's go ahead and look at the next one. I'm going to go ahead and put my 3 on there. It's going to be an open circle at the 3. I'm going to put a -1. I'm going to put a open circle at -1 as well. So I have my 3 regions, A, B, and C. We don't actually have to put the A, B, and C if we don't want to. So I'm going to go in the first region now. I'm going to pick a number. Let's go ahead and use -4 again. So I'm going to go with -4. I'm going to check the first equation. So -4 greater than 3. Is -4 greater than 3? That is false. Let's check the second one now. -4 greater than -1, which is also false. So this region here does not get shaded because they were both false. Let's go ahead and check the middle section. I'm going to use a 0. So 0 greater than 3, false. 0 greater than -1, that is true. So I'm going to shade this middle section. Let's go ahead and check the third region, which is here. I'm going to use the number 5. Oops, I went away. So I'm going to plug in the number 5. Is 5 greater than 3? That is also true, which means this region gets shaded. So my solutions are in the middle section and on the section in the right. And for the number 3, actually, since this section on the right gets shaded, this 3 also gets shaded because I can also test it. It would also be true here. So you can actually shade in that 3 as well. And then it gets pretty much becomes this whole thing here. And this compound inequality actually ends up becoming a simple inequality. So this actually ends up being a simple inequality, x greater than -1. So again, the compound inequality ends up being a simple inequality in this case. Let's go to the next one. All right, number 3. We have 4 and -1. So at 4, we're going to put an open circle. At -1, we're going to put a open circle as well. Check our 3 regions. So let's plug in -5 on the first one. Is -5 less than -4? That's true. So that means this section gets highlighted. Middle section, let's try 0. So 0 less than 4. That is also true. So we just highlight the middle section. And let's check 5. Is 5 less than 4? Which is false. Let's check the second one now. Is 5 greater than -1? Which is true. So that means this also gets shaded. Let's check the open circles as well. Is -1 less than 4? It's also true, so we can highlight this circle here. And is 4, sorry, let's try the 4. Is 4 less than 4? That's false. And is 4 greater than -1? That is also true. So in this case, the whole thing gets shaded. So my answer is all real numbers. So every number is a solution either to the first one or to the second one. Let's go to our last problem. In this case, notice that my inequalities are written as have expressions that need to be solved for x. So we need to actually solve for x. I'm going to add 10 on both sides. Cross that out. Negative 6x greater than negative 30. Divide by negative 6. Remember, when we divide by negative, the inequality switches. So this has to switch out. So remember that minor detail from last quarter. Second inequality, we're going to do the same thing. We're going to subtract 7 on both sides. 10x less than or equal to negative 30. Divide by 10. X stays the same because we didn't divide by a negative. Negative 3. So we're going to go ahead and graph this. We should still have our or in between. So I'm going to put an open circle at 5. I'm going to put an open circle at, or closed circle at negative 3. And I'm going to go ahead and graph these. So I'm going to go ahead and check negative 5 on the left side in this region here. So I'm going to plug it in. So is negative 5 going to be less than? Now check this one first. Less than 5, that's false. Let's check the second one now. Is negative 5 less than negative 3? That is true, so that means this section gets highlighted. All the numbers to the left are solutions. Middle area, let's plug in a 0. Is 0 less than 5? True, so the middle section also gets shaded. And to the right, again, this area here, we don't see the numbers, but we know after 5 comes 6, 7, 8, 9, so let's go ahead and plug in 6. Is 6 less than 5? False. Let's check the second one. Is 6 less than or equal to negative 3, which is also false, so we don't highlight that section. So my answer just becomes this. Again, this one's already highlighted, so I don't have to worry about checking that one. And this just becomes a simple inequality, which is just x less than 5. So final answer will just be x less than 5. That's my simple inequality. Now go ahead and get started on your practice work, and good luck.